So I hope this screen is visible to everyone. So in the yesterday's topic, there are two ways of representing queues. One is array representation and the other one is list representation. So in both the ways, that's why we are studying linked list in front of stacks and queues. So array representation was discussed in yesterday's class, how an insertion, that is NQ operation, is going to be performed. So this is the algorithm which are discussed. This is the algorithms, two different algorithms which are discussed yesterday. One for the insertion of an element into a queue, and the other one is deleting an element from the queue. So what is the check we perform? We are supposed to check the overflow condition whenever we try to add an element into the queue. This is very much common for any data structure. While adding any element into the queue, first of all, you need to check the overflow condition. While deleting an element from the queue, you need to check the underflow condition. So once under that means, while adding an element into the queue, overflow means if there is space, enough space that is available towards inserting an element or not. That's what we are going to check. If it is already in underflow condition, that means the queue is full. So we cannot add any particular element on it. So while deleting an element, we are supposed to check the underflow condition. That means there must be some elements that are to be present in the queue. So because we are performing deletion operation, so there must be some elements of the queue. So that check is supposed to be done as part of underflow condition. Hope these two are clear. NQ and DQ, inserting an operation and deleting an operation.
Yes, sir.
Okay, then we'll move to the other topic, that is, so this is the program, the same algorithm, whatever the explanation that is conducted as part of algorithm, the same thing. Observe this particular program. So might be this is visible to you on the, so I will increase the font size on the cell phones. Why? Because most of the students are watching the class are using cell phones. See, observe this particular insert function. So in this, what we are trying to do, first we are checking the overflow condition. Enter the number to be inserted in the queue and then scan the number. If rare is equal to max minus 1, that is, we are checking the overflow condition. Max minus 1 means array implementation low, the rare always at max minus 1 when the array is completed or full of elements. Full of elements ఉన్నప్పుడు మాత్రమే this rare becomes max minus 1. So at that moment you go for the condition that is overflow. If that means no elements are to be inserted onto the queue, then otherwise if front is equal to -1 and the rare is equal to -1, that means no elements that are present in the queue, then increment the front size and rare size, front position and rare position by 1. That is, front and rare becomes 0. Why these two steps are added in the function? Sindhu and Harika, respond. Manikanta, you need to improve your network. So your voice is not audible to me all the time. You are responding, but at the time, I'm not getting any information from you. Emma, Sindhu and Harika.
Sir.
Why should we need to add these two statements? ఎందుకు ఈ రెండు స్టేట్మెంట్స్ ఎందుకు యాడ్ చేశాను? So in the first statement, we are initializing the number equal to the data type. We are identifying the data type num equal to integer, and then enter the number to be inserted in the queue and scan the number and read the number, whatever be the number that is entered by us. And then these two statements are for checking the overflow condition. That means if rare is equal to max minus 1, print overflow. Else, అంటే that means కాదు, overflow కాదు అంటే what it means? Overflow కాదు అంటే what is the meaning? Sindhu and Harika. Harika, are you in the class?
Yes, sir. Elements ని యాడ్ చేయడానికి ఉంటుంది sir.
Yes, there is a provision for adding elements on the queue. That means there is space. At least one element can be added. ఎంత అనేది తెలీదు. So ఎంత space అనేది we don't require. Whenever rare becomes max minus 1, we cannot add. So otherwise, if it is fails, that means rare is not max minus 1, then you can add elements. But while adding, first of all, why should we need to check these two statements? Anna? Here, if front is equal to -1 and rear is equal to -1, front and rear becomes 0 అన్నాం. అంటే ఏంటి? What is the meaning for that? తెలుసా తెలీదా? If not, I will explain. ఏమా సింధు, ఆర్ యు ఇన్ ద క్లాస్?
Yes, sir.
ఏంటమ్మా ఇది రెండు స్టెప్స్ దేనికి? Suppose it is an empty queue, there are no elements in the queue, first of all, అన్నప్పుడు whatever be the number that is entering, that becomes the first number కదా. క్యూలో ఎవరు లేరమ్మా, it is empty. Now it is empty అని ఎలా తెలుస్తుంది? Whenever front equal to -1 and rear equal to -1, arrowలో the first element position is ఇక్కడ 0 or -1 లేకపోతే 2?
0, sir.
0 దగ్గర ఉంటుంది కాబట్టి if front equal to -1 and rear equal to -1, that means is there any elements that are present in the queue? ఇలా ఉంటే ఉన్నట్టా లేనట్టమ్మా? -1 ఉందంటే
No, sir.
ఉన్నట్టా లేనట్టా?
లేనట్టు, sir.
లేనట్టు అంటే no elements are present in the queue. That means whatever with the number that we are adding, that becomes the first number. అంతేనా? ఫస్ట్ ఎలిమెంట్ అవుతుంది.
Yes,
Is
sir.
it okay, Harika?
Yes, sir.
సో ఫస్ట్ ఏం చేస్తున్నాం? మ్యాక్స్ ఎంటీ స్పేస్ ఉందా లేదో చెక్ చేస్తున్నాం. ఇఫ్ ఎంటీ స్పేస్ ఈజ్ అవైలబుల్, ఇట్ కెన్ బి ఎంటీ క్యూ ఆల్సో. ఎంటీ స్పేసెస్ ఉన్నాయంటే ఎంటీ క్యూ కూడా క్యూలో కూడా ఎంటీ స్పేసెస్ ఉంటాయి కదా. అంటే నో ఎలిమెంట్స్ ఆర్ ప్రెసెంట్. వాట్ ఎవర్ విత్ ద నెంబర్ విచ్ వీఆర్ యాడింగ్, దట్ బికమ్స్ ద ఫస్ట్ నెంబర్. సో వాట్ వీఆర్ సపోజ్ టు డూ, ఈ ఫ్రంట్ ఈక్వల్ టు -1 అండ్ రేర్ ఈక్వల్ టు -1 ఉన్నప్పుడు వీఆర్ సపోజ్ టు ఇంక్రిమెంట్ ద పొజిషన్స్ ఆఫ్ ఫ్రంట్ అండ్ రేర్ బై 1 పొజిషన్. అంటే -1 + 1 ఎంత అవుతుంది? ఫ్రంట్
0, sir.
0 అండ్ రేర్ ఈక్వల్ టు -1 కదా ఇంత ముందు. నౌ ఇట్ ఈస్
Yes, sir.
+1 యాడ్ చేస్తాం. ఎంత అవుతుంది? -1 + 1.
0, sir.
సో ఫ్రంట్ అండ్ రేర్ బికమ్స్ 0. దిస్ స్టేట్మెంట్ ఈస్ క్లియర్? ఏమా అర్థమైందా?
Yes, sir.
ఓకే. ఇఫ్ సపోజ్ దెర్ ఈస్ సమ్ ఎలిమెంట్ లైక్ రేర్ 1 లో ఉంది లేదా 0 లో ఉంది, అంటే ఒక ఎలిమెంట్ ఉంది. ఇప్పుడు ఎక్కడ యాడ్ చేయాలి? సెకండ్ ఎలిమెంట్ ని రేర్ ని ఇంక్రిమెంట్ చేయాలి. రేర్ ఇంక్రిమెంట్ చేస్తే 0 + 1 ఎంత అవుతుంది? నౌ రేర్
1.
బికమ్స్
1.
1 అవుతుంది. ఆ 1 దగ్గర ఏం చేస్తాం? క్యూ రేర్ లో, అంటే రేర్ ఎక్కడైతే పాయింట్ అవుట్ చేస్తుందో దేర్ వీఆర్ సపోజ్ టు యాడ్ నెంబర్. ఈజ్ ద ఫంక్షన్ ఈజ్ క్లియర్? C7, రోల్ నెంబర్ C7, C8.
Sir.
అర్థమైందా చెప్పింది ఫంక్షన్?
Yes, sir.
So why
Yes,
should we
sir.
check if front equal to -1 and rear equal to -1? దీనివల్ల అడ్వాంటేజ్ ఏంటి? What is the need for checking this?
ఎలిమెంట్స్ ని యాడ్ చేయొచ్చు అని.
అవునమ్మా, ఎలిమెంట్స్ ని యాడ్ చేయడానికి ఈ ఫంక్షన్ ఇన్సర్షన్ అంటే అదే. So while inserting, first of all, we are supposed to check the status of the queue. If no elements are present in the queue, that means empty queue. Our inserted element is supposed to be the first element. అంతేనా?
Yes, sir.
అదే ఇక్కడ చెక్ చేస్తున్నాం. If front equal to -1 and rear equal to -1 అంటే no elements are there in the queue, then front and rear becomes 0 and q rear equal to number, add number. అర్థమైందా? అదర్వైజ్ అంటే there are some elements లేదా 1 వరకు ఉన్నాయంటే 2 ఎలిమెంట్ యారే పొజిషన్ 1 లో ఉంది రేరు అంటే హౌ మెనీ ఎలిమెంట్స్ విల్ బి దేర్? రేర్ అనేది యారే పొజిషన్ 1 లో ఉందంటే హౌ మెనీ ఎలిమెంట్స్ ఇన్ ఏ క్యూ? నేను అన్న
2,
క్వశ్చన్
sir.
అర్థమైందా? C7
2, sir.
2 ఎలిమెంట్స్ ఉంటాయి. నౌ ఇఫ్ యు వాంట్ టు యాడ్, యు ఆర్ ట్రైయింగ్ టు యాడ్ థర్డ్ ఎలిమెంట్, అంతేనా? సో
Yes,
1
sir.
దగ్గర ఉంది కాబట్టి ఏం చేస్తాం? రేర్ ని ఇంక్రిమెంట్ చేస్తాం. అదర్వైజ్ అంటే ఎంటీ క్యూ కాదు. ఎంటీ క్యూ కానప్పుడు ఏం చేస్తున్నాం? రేర్ ఈజ్ ఇంక్రిమెంటెడ్ బై 1. రేర్ 1 లో ఉంది, 1 దగ్గర ఉంది. సో ఇంక్రిమెంట్ ద రేర్ పొజిషన్ బై 1. దట్ మీన్స్ రేర్ బికమ్స్ 2 అండ్ ఎక్కడైతే రేర్ పాయింట్ అవుట్ చేస్తుందో దేర్ యూ యాడ్ ద నెంబర్. దట్ ఈస్ థర్డ్ ఎలిమెంట్ కింద యాడ్ చేస్తాం. ఈజ్ ఇట్ క్లియర్ టు ఎవ్రీవన్? C7, C8,
Yes, sir. Clear.
C8
Sir.
అర్థమైందా? అది ఈ స్టెప్స్
Yes, sir.
ఓకే. So B4 and B6 respond.
Yes, sir. Advanced, sir.
So this is what the function for insertion. Then next, delete. So deletion means DQ. So what is the name of the deletion operation? That is DQ operation. So what we are trying to do, delete element. Then, so first of all, we are supposed to check whether the queue condition, there are some elements in the queue or not. While trying to delete any particular element from the queue, first of all, we are supposed to check whether the queue is having some elements or not. If that queue doesn't have any elements, that means empty queue. Can you delete the element B4, B6? If no elements are present in the queue, can you able to delete it? B6?
No, sir.
No. So for that, in yes, no. If front equal to -1, when front becomes -1, we are checking some condition. Respond over
Yes,
here.
sir.
ఈ
Yes, sir.
చెప్పే వరకు నువ్వు రెస్పాండ్ అవ్వు. If front
Okay, sir.
-1, is there any elements that are present in the queue?
No, sir.
No elements. -1 ఉందంటే ఫ్రంటే లేదు.
Front లేదు.
ఫ్రంట్ అంటే the first person who enters into the queue, అంతేనా?
Yes, sir.
So if it becomes -1, that means no elements are present, or front is greater than rare. When front becomes rare, greater than rare, ఎప్పుడు
Yes,
ఫ్రంట్
sir.
రేర్ కన్నా ఎక్కువ అవుతుంది. When you try to delete elements.
Elements.
So suppose there are 3 elements in the queue. ఇది చెప్తున్నాను, అర్థం చేసుకోండి కరెక్ట్ గా. If there are 3 elements in the queue, what is the position of rare? 2, అంతేనా? array of 2.
Yes, sir.
A of 2 లో ఉంటుంది. What is the position of front? A0.
A0.
ఫస్ట్ ఎలిమెంట్ A0 కాబట్టి A0 లో ఫ్రంట్ ఉంటుంది. రేర్ 3 ఎలిమెంట్స్ ఉన్నాయి కాబట్టి A2 లో రేర్ ఉంటుంది. సో సపోజ్ యూ డిలీటెడ్ 1 ఎలిమెంట్, ఫ్రంట్ ఏమవుతుంది?
A1.
యూ డిలీటెడ్ సెకండ్ ఎలిమెంట్,
A2.
ఫ్రంట్ ఏమవుతుంది? A2 అవుతుంది.
A2.
ఇంకా ఎలిమెంట్ ఉన్నాయి కదా, A2 అనేది దాని దగ్గర ఎలిమెంట్ ఉంది కదా. యూ డిలీటెడ్ అనదర్ ఎలిమెంట్, సో ఫ్రంట్ బికమ్స్ 3 అవుతుంది, రేర్ అక్కడే ఉండిపోతుంది 2 దగ్గర. సో అప్పుడే ఫ్రంట్ ఈజ్ సపోజ్ టు బి గ్రేటర్ దాన్ రేర్. అంటే 3 ఎలిమెంట్స్ ని డిలీట్ చేసినప్పుడు రేర్ మాత్రం 2 దగ్గరే ఉంటుంది, ఫ్రంట్ మాత్రం థర్డ్ A of 3 దగ్గరికి వెళ్తుంది. సో దట్స్ వై ఫ్రంట్ బికమ్స్ రేర్. ఎప్పుడంటే when you try to delete all the elements in the queue, అంటే you are going to make the queue as empty. అర్థమైందా? ఎప్పుడైతే మనం ఎంప్టీ క్యూ చేస్తామో ఎలిమెంట్స్ ఉన్నట్లో, then front becomes rare. నేను I think yesterday also I explained with the help of some drawing. So I am going back once again for the better understanding. Here see this particular drawing, the drawing is visible? కనబడుతుందా? What is the position of rare? దీంట్లో పైన 8.1 లో what is the position of rare? ఎక్కడ ఉంది?
Fifth position.
Fifth position లో ఉంది. What is the position of front?
0.
Now you try to delete the element at A0, that is A0 లోది, అంటే 12 ని బయట తీసేసాం. డిలీషన్ ఆపరేషన్ ఒకసారి పెర్ఫార్మ్ చేసాం, 12 బయటకు వచ్చేసింది. వాట్ ఇస్ ద పొజిషన్ ఆఫ్ ఫ్రంట్? 1 అవుతుంది. 9 డిలీట్ చేసాం. వాట్ ఇస్ ద పొజిషన్ ఆఫ్ ఫ్రంట్?
A2.
Now 7 also deleted. What is the position of
3?
Q? 3. Now 18 also deleted. What is the position
4.
of 4? Now 14 also deleted. What is the position of front?
36.
5. ఇక్కడ ఉంది ఎలిమెంట్. Now 36 also deleted. So front should be incremented or not?
Yes, sir.
Front move అయిపోతుంది. When you try to delete,
front will be moved.
Element delete అయినప్పుడు automatically front is moved. Front move అయితే front becomes 6 అయింది, but rear still at 5 itself. Why? Because rear ఎప్పుడు ఇంక్రిమెంట్ అవుతుంది? Only at the time of insertion. Rear is incremented only at the time of insertion, and front is incremented when you perform a deletion operation. Is it clear? So appudu emayindi? Front becomes 6 and rear becomes 5. So front is greater than rear.
Yes.
Front 6, rear 5 kada. Front is greater than rear. Front greater than rear అయినప్పుడు ఇక్కడ ఏమైనా ఎలిమెంట్స్ ఉన్నాయా? Do you find any elements here?
No, sir.
No elements. That means Q is empty. So this is the
Yes.
way our second condition. Igo. ఎప్పుడును ఫస్ట్ రిమూవ్ ద ఎలిమెంట్ క్యూ ఫ్రంట్ లో ఉన్న ఎలిమెంట్ ని వాల్యూలో పెట్టండి, సెట్ ఫ్రంట్ ఈక్వల్ టు ఫ్రంట్ ప్లస్ 1 అంటే ఇంక్రిమెంట్ ద వాల్యూ ఆఫ్ ఫ్రంట్ బై 1 పొజిషన్. సో ఇక్కడ థర్డ్ అంటే ఫ్రంట్ ని ఇప్పుడు డిలీషన్ వైల్ పెర్ఫార్మింగ్ డిలీషన్ వి ఆర్ సపోజ్ టు యాడ్ అండ్ వి ఆర్ సపోజ్ టు
Add
మూవ్ ద
one.
పాయింటర్ front pointer by one location. So what happens here? This front now is placed at 6 and rear is still at 5. So
5.
front is incremented. So no elements are that are present in the queue. So this is the way we are supposed to find the condition for adding an element into the queue. Now we'll go back to the function, delete function. So this is the delete function. So here we are verifying two different conditions. One is front equal to -1
Minus
and
1.
front is
20.
greater than rear. Then print the statement that is underflow
And
and return the return -1. So otherwise that means there are some elements present in the queue. Then what to do? So first remove the value that is pointed by Q front and place it at a value that is, this is the temporary location which can store the deleted element. So now add the element value at temporary location, that is val, and front is incremented. So that's why we are using front plus plus. So with this statement, the front value is moved to another value, that is another position. So front is incremented by one position. Now in the previous case, in the previous example, if you try to delete the first element, in this example, if you try to delete the first element, that is 12, now the array position, initially it is at 0, now it is moved to 1. Front plus plus angane. So front is moved to one location. Now 12 may not be the first element of the queue. So why? Because 12 is removed from the queue. So front may not be, first element may not be 12. So now what is the first element? Once a deletion operation, once you performed one deletion operation, what is the first element in the example? Now what is the front becomes now? What element becomes the front element once a deletion operation is performed on this queue? Row number B6.
Yes, sir.
So what is the new first element? Front element when you perform a deletion operation. Once
7 position.
deleted, then what becomes the first element in this queue?
First position. 9.
That is 9. Data element 9 becomes, which is placed at memory location, that is 1 array in the array. So that becomes the first one. So suppose you try to perform one more deletion operation. Now front may not be 9. Now what is the new element for element with front
Second
location?
position 7.
That is 7. So this is the way we are supposed to perform the deletion operation in the queue. So Sindhu, is it clear? Sindhu and Harika. So all the students
Yes,
are
yes.
informed to copy these two functions. First copy the insert function. So that is highlighted. Make a note of it. So is the function is visible to everyone? Sindhu and Harika,
Visible, sir.
is it visible?
Yes, sir.
Yeah, make a copy of it. So these are the two basic operations which we are going to perform on queues. One is insertion and the other one is deletion. So yesterday also I informed you what is the difference between operations and applications. So these are the two operations. For any kind of application, we are make use of these two operations. While performing any particular application, we are making use of these two operations. Be clear about it. Don't get confused between operations and applications. These operations are going to be used in the application. So make a statement. Roll number C7, are you copying?
Yes, sir. Copying.
Is the function is visible on your mobile phones?
Laptop.
Laptop, huh? Good. B3, B4, B5. Anybody is available in the class? B3, B4, B5. Sandeep,
సార్
వాళ్ళ నెంబర్ నోట్ చేసుకో. B3, B4, B5.
B4 B5 ఆబ్సెంట్ సార్.
B3. What about B3?
B3 ప్రెసెంట్ సార్.
Ask him to make a call to me once the session is over.
ఓకే సార్. ఓకే సార్.
So this insertion function is copied by you.
ఎస్ సార్.
Then copy the delete function. So here there is a case 2, that is once an element is removed, the front is incremented by 1 position, and this is second case. If front is greater than rear, front equal to rear equal to -1. That means no elements that are present here. So Harika, what about these two statements? Why should we need to add these two statements in the program? Harika,
Sir,
why should we need to add these two statements in the deletion function?
empty queue.
So finding whether the queue is empty or not. Can you able to delete an element from an empty queue?
No,
Is
sir.
it possible? No. So for that, we are verifying. So one thing is, if front equal to -1 and rear equal to -1, no elements that are present in the queue. Or otherwise, if front is greater than rear, in that case also, no elements that are supposed to be there in the queue. We are supposed to initialize when no elements are present, means front becomes rear equal to front and rear becomes -1. So that means -1 means no elements that are present in the queue. Return the value that is stored in the front element. We are trying to delete the queue front element, so which is stored in the value. So return the value that is deleted. So copy this function also, deletion function. Roll number 1. Who is roll number 1? Roll number 1, are you available? So there is one more function here. Manikanta, note down his number. Roll number 1.
Okay, sir.
He or she, boy or girl? Roll number 1.
Girls, Chandana, sir.
Girl. Sindhu, make a note of her number.
Okay, sir.
Okay, now this is one other function, peak. So why should we need to go for a peak function? What is the use of peak function? Just like in the stack, we discussed in the stack, as part of stacks, we discussed peak function which returns the topmost element. So topmost element, but here while deleting an element from the queue, we are supposed to delete the first element, that is where the front pointer points, there that particular element is supposed to be returned. So that's why here the peak function which returns the queue front element. So if at all, for that, prior to return this particular value, we are supposed to check there must be some elements that are to be present in the queue. If no elements are present in the queue, we cannot return anything. If some elements are present, then ultimately the first element that is to be deleted is pointed by front, and that queue front element is supposed to be returned by peak function. So that's why we are verifying that whether a queue is empty or not by make use of this condition. That is, if front equal to -1, is there any elements will be there? Front equal to -1 unte Is there any elements that are present in the queue?
No, sir.
No elements. If front becomes -1 means no elements that are present in the queue. So this condition returns queue is empty, or otherwise one more condition, that is if front is greater than rear, that means, as I already explained to you with the help of example, when the front becomes rear, after deleting good number of elements from the queue, so at one state, when front equal to rear equal to pointed by one element and you perform deletion operation, then definitely the front is incremented by one position and front should be greater than rear. When front is greater than rear, then queue is ultimately empty. So you cannot return any value when the queue is empty. So that's why these two conditions are verified. Once these two conditions are verified and these two conditions are failed, then we return the queue front value for peak function. So this is what happened in peak. And ultimately there is one more function which is supposed to be used for display. So once you performed a good number of insertion operations and deletion operations, or only insertion operations, so you want to check the status of the queue, then this display function is going to be used. So when the items are supposed to be under display function, which tells you the status of the queue, how many elements that are present in the queue. So how many elements? For that, first we are supposed to go for checking the status of the queue. If it is empty, we cannot return or we cannot display anything. If there are some elements in the queue, then we are supposed to display all the elements. For that, we are supposed to use this particular. So for I equal to front and I is less than or equal to rear, increment the array position of I by 1 and then display all the elements of Q. So it tells you that if 5 different elements are there, I equal to initially I becomes 0, I equal to 0 and I is less than or equal to rear. That means wherever rear points, rear equal to them, 5 different elements are there, rear pointed at A of 4. So till that point, we are supposed to increment the I position by 1 and return the value of 5. So which displays all the elements that are there in the queue. So this is what the functions. So copy this peak function as well as display functions. These two functions. Hope the screen is visible. Or can I increase the size of the font?
Visible.
Now see, the font size is incremented. This is the basic operations on a queue in array implementation. So this particular program may come for 8 marks in the examination. You need to write all different 4 functions. Copy it, make it fast. So today we will see, after this, we will see the linked implementation of queue. Now roll number 2, are you available? Roll number 2. Meantime, the other students can copy these two functions, peak and display. Roll number 2, are you available?
Yes, sir, available. Hello.
Yeah.
Available.
So what will be the program that is explained today? Is it understood by you?
Understood, sir.
The program for basic operations of queue implementation using arrays.
Yes, sir.
Okay. So copy these two functions. Have you copied it or copying?
Copying, sir.
Do it fast. Today we'll move to the other topic, that is linked queues, basic operations of queue using linked list.
Okay, sir.
So what are the important points, highlights in this class so far discussed?
Rare
So
Rare
there are 2 operations, basic operations on queues. One is insertion and the other one is deletion. Insertion we can call it as NQ operation And for deletion, it is to be called as dequeue operation. While adding an element into the queue, we are supposed to check the condition overflow. And while deleting an element from the queue, we are supposed to check the condition that is underflow. And for while adding an element into the queue, we are supposed to, all the time, we are supposed to increment the rare position by 1. While while deleting an element from the queue, we are supposed to increment the position of front by 1. So that's why if 5 different elements are there in the queue, if all 5 elements are deleted, the queue front is supposed to be greater than rare condition. That means which returns the status of the queue is empty. So these are the highlights of the today's class about queue implementation using arrays. Is it understood? Roll number 2.
Yes, sir. Copying, sir.
Sandeep, have you copied it?
Copying, sir.
Since so many students are having engineering drawing as supplementary subject, so we are planning to arrange engineering drawing separate classes for engineering drawing for getting success in the supplementary examinations. So that timetable is supposed to be displayed soon. So you people have to attend online classes for drawing. If you want to clear some of your doubts, you can come to college and meet the concerned staff member. That possibility also available. But with by taking some security measures, safety measures, you are supposed to come and meet the concerned staff member for clearing all your doubts in engineering drawing. So yesterday I got the list, both the A section as well as B section lists. So out of it, so many students are failed in engineering drawing only. And it is very much strange that some of the students like B3, B4, B5, these 3 students are failed in fundamentals of computer science, FCS. I don't know what kind of difficulty they found in FCS. So that's why Manikanta, you ask them to call me after the class B3, B4, B5, okay? So now I'm moving into other section. Yeah, Sandeep. Sandeep, you tell
Okay,
them to
sir.
make a call to me after the class.
Okay, sir.
Now we are moving to linked representation of queues. So as we already know that in linked list, each and every node is having 2 different fields, one for the data and the other one is for the next address field, which can, that particular field belongs to the next address one. So it simply tells you what is the next node to the existing node. So whereas in the case of this case may not be found in arrays. Why? Because in array, we are having sequential locations, sequential addresses for each and every node. So A0, A1 is followed by A0 and like that. But whereas in the case of linked representation, so the elements may be at any location in the memory, but how to find the next element is because with the help of the next address field, which contained in a node. So the only disadvantage with the linked list is it occupies more space when compared to array, and the biggest advantage with linked list is it dynamic in nature. Why? Because whatever be the kind, wherever it is, you can simply identify what is the next element to the existing element. So, and one more drawback with the array is if you delete, suppose the array size is 10, if you delete the first 5 elements, but you cannot move back to the, you cannot refill the first 5 elements, the empty positions that are available in the array, or otherwise there are two cases why, that is, you can move all the elements towards left after deletion. That is one case, but moving all the elements towards back, that is expensive. So instead of that, so we are making use of a linked list representation using a linked representation of queues, which is more effective than the array implementation. So array slow, can you able to shrink the array size once it is initialized, or can you able to extend the size of the array once it is initialized while the program is running? Sindhu and
No, sir, we
Harika.
can't.
So we cannot increase the size of the array once it is initialized, and you cannot decrease the size of the array once it is initialized. That means array implementation of queues having static implementation. But whereas in the case of a linked list representation, you can add any number of elements if the space is available. You can add or you can shrink. So these two operations can be very much helpful in the case of linked list representation of queues. So each and every field, as we know that each and every node will contain two different fields, one for the address and the other one is for the data. Here also there are two different basic operations. One is insertion and the other one is deletion. So see this diagram in 8.6. So this is the linked queue, each with how many nodes? So there are 8 different nodes that are present here. So the front pointer pointed at with a data value that is a node with a data value that is 9, and the rear is pointed at the data value with 5 and with a next address field as null. So that means this is the last node of the list and this is the first node of the list. So list implementation using queues. So what is the value that is placed here in the first node's next address? What will be the value? It simply tells you the next, what is the next node of node number 9. So what is the value that may be here? Sindhu or
1.
Harika? That is 1.
1, sir.
So here in node number 2, what is the next address field value? What is the
7.
value here?
7, sir.
7. So like that, we can move up to node number 5, that is 8th node of the queue, and which contains the value, data value as 5 and next address value as null. Whenever a particular node's next address field contains null value, then that becomes the last node of the queue. That is, rear pointer points at the last node. So if any particular node is to be deleted, so we are supposed to delete the first node. So what is the node to be comes out when you perform a deletion operation in this queue? If you perform a deletion operation on this queue, what is the node to be deleted?
9,
First
sir.
node.
The one first node, the one pointed by front pointer, and this particular node is supposed to be deleted and it is supposed to be comes out. Now the remaining elements in the queue are 7. The remaining elements in the queue are 7. Initially it is 8. We performed some deletion operation. So the first element was deleted. So remaining elements are 7. If you try to add a new element onto the queue, like this 9 is supposed to be added as a new element. So what will be the change? Here you can observe as a previously rare value. So what is the change that you may observe? Add the element 9 and add the next address field as null. Add the value next address field in the next address field as null, and this previously last node's next address field was changed to what is the value it may contain? Sindhu?
9, sir.
9. So 9 is supposed to be added here. Then 9 becomes the last node. 9 becomes the last node. This is the way the insertion operation is going to be performed, and this is the figure 8.7 displays the removal of the first node from the linked queue. So for that, this is the algorithm. Hope this algorithm is visible to everyone.
Yes, sir.
Algorithm for inserting an element into the linked queue. First of all, while adding an element into the queue, we are supposed to get the node from the memory. So that is what happening in the step number 1. So allocate memory for the new node and name it as PTR, that is pointer. So first get the node from the memory. How to get the node from the memory? In a linked list. So that is already discussed as part of your linked list explanation. How to get a node from the memory? While adding a node into the linked list. Here we are using linked list implementation for queues. How to get a node? Where the available nodes are present in the memory. The free nodes are available in the available list on the memory. There is a list that is available in the memory which contains all the free nodes. We are supposed to get the first node from the available list and change the pointer to avail next. So this is what we practiced in the linked list implementation. Emma, Gurtochniya?
Yes, sir.
Harika?
Yes, sir.
In the memory, there are good number of, if any free nodes that are available in the memory, all the free nodes are available in a available list, and you are supposed to get a new node from the available list and change the avail pointer to next available. So these are the two activities which are discussed in the as part of your linked list implementation. ఇది మాట్లాడుకున్నాం కదా. గుర్తొచ్చినాయా రాలేదా అంటే మీరు సమాధానం చెప్పట్లా. లింక్డ్ లిస్ట్ లో ఇన్సర్షన్ ఆపరేషన్ ఎలా చేశారు? సింధు అండ్ హారిక.
Sir, yes, sir.
లింక్డ్ లిస్ట్ లో ఇన్సర్షన్ ఆపరేషన్ ఎలా పెర్ఫార్మ్ చేశారమ్మా?
మెమరీ నుంచి
Available list
మరి అదే
means
చెప్తున్నాను మళ్ళీ, ఎస్ నో చెప్పరే. So there is a available list which contains all the free nodes in the memory, and we are going to get a new node from the memory through available list. Available list నుంచి తీసుకుంటాం అంతేనా? So
Yes,
that
sir.
is this one. Allocate memory for the new node and name it as pointer, that is PTR. Okay. Now set pointer data equal to value. Put some value. ఒక కొత్త వాల్యూని పెట్టండి దాంట్లో. ఓకే, లైక్ దిస్ వన్. ఏది 9 అనేది తీసుకోండి. గెట్ ఏ న్యూ నోడ్ ఫ్రమ్ ద మెమరీ అండ్ యాడ్ వాల్యూ 9 onto it. While trying to add an element into the queue, where to add? We are supposed to add at the rear end. అంతేనా? క్యూ లో ఇన్సర్షన్ ఎక్కడ జరుగుతుంది తల్లి? దిస్ ఇస్ ద ఇనిషియల్ రేర్. అంతేనా? This is the rear position, and we are trying to add a new node next to the rear. Now, దాన్ని rear కింద చేసేస్తాం. These are the 3 simple steps. For that, what we are trying to do, get a new node from the memory. So this is the new node, and add data on it. That is 9 is added here. That is here. This is the second step. Set pointer data equal to value. Now, if front equal to null, అంటే no nodes that are present అయితే అప్పుడు ఏమవుతుంది? Our new node becomes the first node. While adding a node into the queue, first we are supposed to check the status of the queue. If no nodes are present in the queue, then add the new node as a first node. దాన్ని ఇక్కడ స్టెప్ నెంబర్ 3 లో చేస్తున్నాం. ఈ ఎల్స్ బిఫోర్ వరకు ఏం చేస్తున్నాం? ఈ ఫ్రంట్ ఈక్వల్ టు నల్. ఎప్పుడు ఫ్రంట్ ఈక్వల్ టు నల్ అవుతుందా? when front becomes null.
if no elements are present.
No elements are present in the queue. అంతేనా? Then అప్పుడు ఏం చేస్తాం? Send front equal to rear equal to pointer. అంటే రెండు అదే నోడ్ అవుతుంది. New node becomes the first and last node. And set front next equal to rear next equal to null. ఇప్పుడు ఇదే ఒక్కటే నోడ్ ఉందనుకో క్యూలో, ఇది డేటా పోర్షన్, అండ్ front to rear both pointed at the same element or the new element, and దాని యొక్క నెక్స్ట్ అడ్రస్ ఫీల్డ్ ఏముంటుంది, which contains null value.
Null point.
null value ఉంటుంది. నేను అన్నది అర్థమైందా?
Yes, sir.
C7, C8, C7 and C8.
Yes, sir. C8.
ఇక్కడ ఫస్ట్ స్టెప్ లో ఏం చేస్తున్నాం, గెట్ ఏ నోడ్ ఫ్రమ్ ద మెమరీ. సెకండ్ స్టెప్ లో కీప్ సమ్ వాల్యూ. అంటే 9 నే చూడండి, ఈ బెటర్ డోంట్ సీ ద అదర్ లింక్స్. ఈ 5 కూడా చూడొద్దు, ఓన్లీ 9 నే అబ్జర్వ్ చేయండి. గెట్ అ న్యూ నోడ్ ఫ్రమ్ ద మెమరీ, యాడ్ సమ్ డేటా ఆన్ ఇట్, దట్ ఈస్ 9 నాట్ ఇట్. ఓకే, నెక్స్ట్ ఏం చేస్తున్నాం, సపోజ్ దేర్ ఆర్ నో నోట్స్ దట్ ఆర్ అవైలబుల్ ఇన్ ద లిస్ట్, దట్ మీన్స్ ఎంటీ క్యూ లో ఉంది. ఎంటీ క్యూ ఉన్నప్పుడు ద న్యూ నోడ్ బికమ్స్ ద ఫస్ట్ నోడ్. C8 and C7.
Yes, sir.
Whatever be the new node which is got from the memory becomes the first node. అదే అవుతుంది.
Yes.
అదే ఇక్కడ చెప్తున్నాం. If front equal to null, that means no nodes that are present are empty queue అయితే, then first node set front equal to rear equal to pointer. అంటే ఏదైతే ఈ పాయింటర్ అనే నోడ్ ని తెచ్చుకున్నాం మనం మెమరీలోంచి, that becomes the front as well as rear. లిస్ట్ లో క్యూలో ఒక్కళ్ళే ఉన్నారనుకోయ్యా, క్యూలో ఒక్కడే ఉంటే అతనే ఫ్రంట్ అతనే రేర్ అవుతాడా అవుడా?
Yes, sir.
అదే ఇక్కడ చెప్తున్నాం. సెట్ ఫ్రంట్ ఈక్వల్ టు రేర్ ఈక్వల్ టు పాయింటర్, అండ్ సెట్ ఫ్రంట్ నెక్స్ట్ ఈక్వల్ టు రేర్ నెక్స్ట్ ఈక్వల్ టు నల్. ఫ్రంట్ నెక్స్ట్ అయినా ఇదే. ఇప్పుడు ఈ నోడ్ యొక్క ఇదే ఫ్రంట్ ఇదే రేర్ అయితే ఈ వాల్యూ ఏమవుతుంది, ఈ ఫీల్డ్ దిస్ బికమ్స్ ద ఫ్రంట్ నెక్స్ట్ యాజ్ వెల్ యాజ్ రేర్ నెక్స్ట్. ఇక్కడ నల్లే ఉంటుంది. అదర్వైజ్ అంటే దేర్ ఆర్ సమ్ ఎలిమెంట్స్ లైక్ దిస్, ఇలా ఉన్నాయనుకో, 1 2 3 4 5 6 7 ఎలిమెంట్స్ ఉన్నాయి. మన కొత్తగా తెచ్చిన ఎలిమెంట్ ఇది 9. నౌ వీఆర్ సపోజ్ టు యాడ్ 9 యాజ్ ఏ లాస్ట్ ఎలిమెంట్. అలాంటప్పుడు ఏమవుతుంది, సెట్ రేర్ నెక్స్ట్ ఈక్వల్ టు పాయింటర్. అంటే రేర్ నెక్స్ట్ అనేది దీన్నే పాయింటర్ కింద చేస్తున్నాం, అండ్ సెట్ రేర్ ఈక్వల్ టు పాయింటర్. ఇక్కడ రేర్ నెక్స్ట్ యాక్చువల్గా ఇది కదా రేర్ నెక్స్ట్, ప్రీవియస్ రేర్ ఏది
5, sir.
ఈ నోడ్ ని యాడ్ చేస్తున్నాం కాబట్టి రేర్ ఇక్కడ ఉంది. రేర్ నెక్స్ట్ ని ఏం చేస్తున్నాం అంటే న్యూ నోడ్ కింద పెడుతున్నాం. న్యూ నోడ్ అంటే ఏంటి, పాయింటర్ కదా. సో సెట్ రేర్ నెక్స్ట్ ఈక్వల్ టు పాయింటర్ అండ్ సెట్ రేర్ ఈక్వల్ టు పాయింటర్. అంటే మూవ్ ద రేర్ పాయింటర్ బై టు ద న్యూ నోడ్. ఈ నోడ్ కి రేర్ మూవ్ చేస్తాం. అండ్ సెట్ రేర్ నెక్స్ట్ ఈక్వల్ టు నల్. ఇక్కడ నల్ వాల్యూ అనేది పెడతాం న్యూ నోడ్ లో. నౌ దిస్ నోడ్ బికమ్స్ ద పార్ట్ ఆఫ్ యువర్ క్యూ. ఇది
Yes,
పార్ట్
sir.
ఆఫ్ ద క్యూ అయిపోయిందా?
Yes, sir.
So this is the way we are supposed to add an element into the queue. Is it understood? Emma, Harika, Sindhu, అర్థమైనయా ఈ 3 steps దేనికి అనేది?
ఎస్ సార్.
రేర్ ఇక్కడ ఉంది, యు ఆర్ యాడింగ్ ఏ న్యూ ఎలిమెంట్ దట్ ఈస్ 9. సో అప్పుడు ఏం చేస్తున్నాం, ఇక్కడ రేర్ నెక్స్ట్ లో ఇంతకుముందు నల్ ఉంది, ఇప్పుడు ఏం చేస్తాం, పాయింటర్ పెడుతున్నాం. దట్ ఈస్ పాయింటర్ ఈస్ న్యూ నోడ్. అంటే 9 అనేది ఇక్కడ పెడుతున్నాం. ఇక్కడ 9 పెట్టి ఏం చేశాను, రేర్ ని ఈ నోడ్ కి మూవ్ చేశా. ఎందుకంటే దీని నెక్స్ట్ నోడ్ కింద ఇదే వచ్చింది కాబట్టి రేర్ ని మూవ్ చేశాను. నెక్స్ట్ రేర్ యొక్క నెక్స్ట్ లో నల్ పెట్టాను, అంతే. నౌ 9 బికేమ్ ద లాస్ట్ నోడ్ ఆఫ్ ద క్యూ. దిస్ ద వే we are supposed to add an element into the queue. Is it understood? Emma,
ఎస్
అర్థమైందా
సార్.
these 3 steps? All of you copy these 3 steps from your textbook and practice it. Okay? ఇవి డ్రాయింగ్స్ పేపర్ మీద వేసుకుని ఫర్ ఈచ్ స్టెప్ ఏమవుతుందో చెక్ చేసుకుంటూ ఉంటేనే మీకు అర్థమవుతుంది. ఇది ఫస్ట్ వన్ అంటే గెట్ ఎ నోడ్, సెకండ్ వన్ యాడ్ వాల్యూ, థర్డ్ వన్ దిస్ ఈజ్ ఫర్, ఇక్కడ కొటేషన్స్ లో పక్కన రాసుకోండి. ఏది కోట్స్ లో ఏమని, ఫ్రంట్ ఈక్వల్ టు నల్, దట్ మీన్స్ ఎంటీ క్యూ అనేది ఇక్కడ రాసుకోవాలి. కండిషన్ అదే కదా. అప్పుడు మనం ఏదైతే న్యూ నోడ్ ని తీసుకొచ్చామో పాయింటర్ ని, దట్ బికమ్స్ ద ఫ్రంట్ అండ్ నల్. తర్వాత ఈ 3 పాయింట్స్. Hope all the students are understood these concepts. Okay, now here I stop the class. Okay, thank you all. Manika,
Thank you, sir.
Sandeep, B3 B4 B5 నాకు